Hello everyone. I welcome you all for this session on Agile estimation and planning. So this is one of the topics in PMI-ACP certification exam. Okay. So in this session I'll be covering on how do we do estimation and how do we do release planning. Okay. And if you have any question, you can, like the way our moderator suggested, you can ask your question by chatting through chat window or by through your voice so that I can unmute and hear what you say. Okay. So in this session we will be focusing on how do we do estimation in agile projects, and also then how do we use this estimation knowledge to do the release planning. Okay. So the various topics I will be covering today under the agile estimation is how do we do the sizing of the user stories, okay, by using relative estimates concept, and what is the story points and how do we use the story points for estimating the size, okay, and what is also called ideal days, which is another alternate unit used for estimation in agile projects, and what is planning poker estimation and how do you use this planning poker method for agile projects, and how do we use this for estimating product backlog size. Okay, and also we'll touch upon a little bit on what is affinity estimation and how do we use this in agile projects. Okay, and then we will also discuss a little how do we do release planning by using the knowledge of estimation, okay, and determine the product backlog size, and then we determine how many iterations and this project requires, or when the client comes up and gives you how many features, suppose we have X features, then folks, can you please tell me how many iterations you would require and what is the date, when you can release. So all that we will discuss in the release planning. Okay, so let's proceed. So agile estimation is quite different from traditional estimation. So traditional estimation, I think some of you must have already heard that we use the units like kilo lines of code, function points, use case points, things like that. These are some of the various estimating units used in traditional estimation methods. Okay. But in agile estimation, we don't use any of these units. So, and the way in which we do the estimation in agile is completely different from the traditional estimation. Okay. So some of the units that we use in agile estimation is, one is ideal days and story points. So these are most popular units used currently throughout the industry. So let's discuss how do we do this. Okay. So before we get into the estimation, there are certain things which we should know when we start the project. So like example, we are building a software product. How the product management in Agile is done. So normally the product management in Agile relies on multiple levels of planning. So first, the level of planning is someone gets a product idea, and that using that idea, the vision of the product will be clearly defined. So once a product vision is defined, then it will be defined in the form of roadmap, the product roadmap, where the product roadmap will have multiple releases. Okay, so then there will be a release roadmap, and every release will have multiple sprints or iterations. Okay, and every sprint will have tasks which are to be executed on daily basis, and also that each task will be done by one or the other agile team member. So who is going to do this task, what is this task and how long this task is going to take. All this will be clearly identified before we execute the activities. Okay, so there has to be, what I'm trying to say in this slide is, there has to be proper connection from the product vision to the daily task what team members do it. In case if it's not happening, then there'll be a mismatch. So then automatically the chances of delivering or chance of meeting the product vision will be less. So hence everyone should take care. Even at a daily task, there has to be proper alignment to the product vision. So let us see how we will ensure this in Agile projects. So, and also the approach for planning in Agile, this is a little bit different. Okay, so the picture what it is being shown to you is something called a planning onion. So it is in the shape of onion, okay, and it is called a planning onion. Okay, if you look at the topmost layer, the outer layer, it starts with a strategy, the product strategy. So once the product strategy is clearly laid down, then it leads to multiple portfolios. Okay, and every portfolio will have certain products, and every product will have certain releases, and every release will have multiple iterations or sprints, and every iteration will have daily task. Okay, and so here the Agile teams, they do get involved from release onwards. That means their job is to do a release planning for a given set of features, and once the release planning is done, then for particular release how many iterations is required, and then when they are going to start a particular iteration, they have to do the iteration planning. So, okay, there are two levels of planning done in Agile projects. So normally the release planning is done in the beginning of the project. That means when the high level scope is defined, the team will get a high level scope in the form of a charter or a vision statement, things like that. So once team comes to know the high level features, then based on that, the team, whatever understanding they have, based on that they do the release planning at the beginning of the project. Okay, and then they do the iteration planning when they are going to start every iteration. They don't do the iteration planning for all the iterations. They will do the iteration planning only when the particular iteration is going to start. So let us discuss how do we do these things. Okay, so before we get into the estimation, again we have to know what is the scope of the project. See, unless we know what is the boundary, unless we know what is the scope of the project, we will never be able to plan clearly. Okay, and one thing in Agile is it will not expect you to have complete clarity, but at least there has to be some high level information. Like example, we have an ATM software or ATM system. So ATM system has got set of features like withdrawing cash, okay, transferring funds, or opening a fixed deposits, like that. So the product vision statement should document certain things to start the project so that team gets some momentum. Okay, and this plan gets refined as and when the particular iteration gets over. So it is completely different from a traditional project where we do the plan for all the entire deliverables, and and that plan will not change. We assume that the plan do not change. Whereas here in Agile, it works with a lot of uncertainties. So when the project has got uncertainties, it's difficult to make a full-fledged or a complete plan. So hence, the agile projects, they do not insist too much on a detailed plan, but team should start somewhere. So they should get the momentum going. So for that, the important thing is first is to defining the product vision statement. So the product vision statement sets a ball rolling. So it documents minimum three things. One is what this project or what is this release is going to accomplish. Okay. So maybe like the example which I gave just now. So if you have a ATM software to be developed, what are the features that are going to be there in this release? So that has to be uh, written. Need not be in detail, just listing, okay, or maybe whatever the high level information. Okay. And why is it required? What is the use of this project? What is the business case? So then how do you accept this project, or how do you say this project is successful? So what are the criteria? Okay, so these three things should be written in the beginning for any agile project. So this is something like similar to a project charter in a traditional project. Okay, and again I am insisting, or again I am stressing or emphasizing here that so the vision statement which documents what, why, and the success criteria should not be very long. Okay, maybe it can be in the form of just one A4 size paper. Okay, one A4 sheet, not like lengthy 15-page, 20-page documents. Again, see, the whole agile expects you to minimize the documentation and just enough documentation. It expects always the team to do just enough documentation at any point of time, and the any further activities the happens through evolution of these documents, okay, by constant evolution as and when that feature is completed. Okay, so with this, so we will come to the uh, next topic. So agile estimates are initially or normally will be in the form of relative estimates. So it may not be suddenly easy for you to grasp what it is. What is exactly agile estimates means in the form of relative estimates. So for that, let me take you through a very familiar example. Okay, so let us assume that there is a 3-bedroom house. Okay, so bedroom 1, bedroom 2, bedroom 3. So all 3 bedrooms are equal in size, and assume living room is twice as big as bedroom, and there is also kitchen. Okay, suppose I ask you that this is a new building. Assume that you are the only one painter, and to paint this kind of building, how long you are going to take? What will be your answer? So this question I am asking you. So if you have any answers, maybe in terms of days or like that, please type your answers in the chat window. So let us spend some time. So then we will take the discussion further. Uh, Okay, Frank. So I think Frank, you want to ask a question. So maybe you can type what you want to ask. So please type your answers. Maybe you can say in terms of days. Okay. Okay. John says 6 days. Okay. And if, okay, John also says if bedroom one is doing to take a day, then it should take 6 days. Okay. Nitin says 12 days. Okay. Pablo says living room 1/3. Okay. Ajay says 8 hours into 3. Okay. Luis says 5 days. Okay, fine. So everybody has some type of answer. Okay, good. Okay, so okay, now let us use one way of doing estimation. Suppose you call a painter to your house. What normally he will do? So he will ask you, okay, can I observe the entire house? Okay, please allow me to see. So moment you allow him to see everything, so he will go and observe each and every room, and then he comes and probably tells you, okay, sir, I'm going to take this many days. So what did he do in this process? In this process, he did some calculation. So either he has used his past experience, or with some amount of gut feeling, he gave some estimation data. So similarly, we will also do something like that. Okay, so okay, so let us assume bedroom 1 takes X amount of work. So let us not worry too much about what is the size of the bedroom. So assume bedroom 1 takes X amount of work. So since I said all bedrooms are equal in size. So let us give some number. So for bedroom 1, I can give 2 or you can give 3. So if you give 3, that means bed X means 3 for you. If I give 2, X means 2 for me. Okay. So in this case, I have given bedroom 1 is equal to 2 points. It is a random number. It doesn't have any significance. Just give some number, random number. So since I gave bedroom 1 2 point, naturally I have to give 2 points to other 2 bedrooms because other 2 bedrooms are equal in size. And I also mentioned you that living room is twice as big as bedroom. So since living room is twice as big as bedroom, so it will take 2x as the amount of work. So we have to give the points 4. We have to multiply it by 2 times. Okay. Now coming to the kitchen. Kitchen is smaller compared to living room. But still, why did I give 4? So this question is for you. Okay. So Pablo says it is more complex to paint. Okay. So Frantisek, he says it has furniture in it, so that can't be moved. Okay. Okay, good. Any other answer? Why did I give kitchen 4? 4 points. Even though kitchen is smaller. Okay, so Ajay says it needs additional coating. Okay, complexity, unknowns. Okay, Mike says it complexity and unknowns. Okay, good, good that you're giving you started thinking and giving some useful answers. Yes. So what it means here is, see, even though kitchen is smaller, but the complexity of painting the kitchen is difficult. It is more. Okay, so kitchen will have certain cabinets, kitchen will have different place to keep the kitchen utensils and all that. So when you're painting the kitchen, the complexity of painting the kitchen is more than the living room. So that is why even though the kitchen is smaller in dimension, but still the effort when you start painting the kitchen will be equivalent or more than the living room. So that's why I have given 4. Okay, so in the sense, what we are trying to say here is, it's not just only the dimension of the room is going to decide the size. It is also the complexity. The complexity of the work is also important. Okay, so let us say now we have 5 features instead of, let's come back to software. Assume there are 5 features. So there are 3 features are equal, like, which are almost equal. Okay, so they equal in, they take same amount of lines of code. So then we will give 2, 2, 2. Okay, and assume there is a 4th feature which takes twice the amount of lines of code compared to the earlier feature. Then it will be 4. And there will be 5th feature which will take very less lines of code, but it is complex. Okay, so then again we'll give points 4. So it is not just only the feature, the lines of code that will determine, it also the complexity of the feature that will also determine the size. Okay, and these points are all randomly given, and they are all relative to each other. If I ask you what is 2, it is difficult to tell. At the most you can say 2x. 2 means x bedroom is equivalent to 2. If I ask you what is living room, 4 means it is a, it does not have any particular unit. It is a unitless number. So what you can say is, okay, living room takes twice the amount of work of bedroom. So that means we are doing relative estimation here. So there are some advantages of doing relative estimation. Some of the advantages is that when we do the estimation relatively, it is quicker, and also we don't have to worry about the fundamental unit. So we don't have to know about the unit of bedroom, whether it is in terms of square feet or whether it is in the terms of square meter, things like that. Okay. Like example, let's take one more example. So let us say I ask you to estimate the height of these buildings. There are so many different buildings in this. Okay. So is it easy for you to estimate? It's not so easy, right? So estimating all this height of each of these buildings is going to take a lot of time, and also it is not so easy. You have to go and literally measure the height of every building. Instead of that, I say, let us say this building, which is near to this where I have placed my cursor, is 1 point. Assume this height of this building is 1 point. Can you not estimate the height of other buildings relatively to this? It is much easier. Like one can say this building is 5, this is 6 times, this could be 10 times, this could be 15 times, something. Okay. So in this process, when we are doing this relative estimation, the time it takes will be less and it is quicker. Okay, so this is very important why we use this concept of relative estimation in Agile. Because now coming back to the Agile software projects, so when the client comes and tells you, folks, I have got X number of features, can you please tell me and can you estimate and tell me how many sprints or how many iterations you can do this, and approximately in how much time you can finish. So let us say you start doing everything in detailed estimation, thinking about absolute numbers. Then assume when you do it, it may come to somewhere between 5 to 6, 5 sprint to 6 sprints. Then you don't have to go and worry about exactly determining whether it is 5.333 sprints or 5.44 or 5.45 sprint. So you don't have to go to that decimals. Client will not be interested that to go to that detail. What client will be interested is either you have to say to the client 5 sprints or you have to tell 6 sprints. Okay. So let us say to be on the safer side, we say 6 sprints. So you in that to that extent you can do estimation faster, but you should not take longer time to do all these things. Okay, we will do everything in detail and then we will come to you. So then the whole point of spending time in Agile is defeated. You should not spend too much time in Agile or doing the entire estimation, because the client will not be interested in the beginning to get into the complete details about the estimation. At the most you can say 5 sprint or 6 sprints in a meaningful number. Okay, so what it means is by doing relative estimation you can do the estimates quicker, but it will be little bit approximate. Okay, so that is fine. We are just now we discussed, we don't have to be precise estimate, we don't have to do the precise estimation. Okay, so with that, so let's come to what is this story point. The story point is one of the units used in estimation. Okay, this example, what is story points means, like the points what we gave here for bedrooms, okay, or for residents. These points are called residential points. Let us say we replace this with different type of dogs, like where maybe you can say Alsatian, there's a German Shepherd, there is a Doberman, okay, there is a Pomeranian, like that. So depending upon the size of the dog, if we give the points, then it becomes doggy points. Instead of that, let us say we replace this with uh, user stories. User stories are one of the ways of writing the requirements in Agile. If you replace this with 5 user stories, there are 3 same type of user stories, and fourth one is bigger, twice the bigger than the earlier user stories, and fifth user story is smaller but it is complex. Then these points are called story points. The points which are used in conjunction with user stories, the points are called story points. Okay, so they are normally, they, if you tell in simple terms, it tells how hard is particular story. The bigger the number, that means bigger the higher the story points, that means that user story or a feature takes more time. If the story point number is less, that means such a user story or feature is less, takes less time. Okay, so what one thing you should know is, when you are determining size, you should know the complexity and the effort. That is most important. It's not just only the effort, you should also add complexity factor to determine the size. Okay, so there are different types of scales used in Agile estimation to do the story point based estimation. One is Fibonacci scale. In the Fibonacci scale, we use the estimation of story points like 1 story point, 2 story point, or 3 story point, like that. So the user story is a 3 story point, we'll say 3, 5, like that. Okay, the scale follows the pattern like any number is the sum of the last 2 numbers. Okay, if I say 3, the last 2 numbers is 2, 1. 2 plus 1 is 3. So the 5 is nothing but last 2 numbers is 2 plus 3. Okay, 5. So 8 is 5 plus 3. Okay, so the pattern of Fibonacci scale is like that. So what it means is, when we are estimating the user stories, let us say there is a user story which is somewhere between 3 and 5. Okay, we don't have to know whether it is exactly 4 story point. Either it is 3 story point or it is 5 story point. Okay, so again, if the user story is between 5 and 8, you don't have to really know whether it is 6 story point or whether it's a 7 story point. So 6 and 7 is missing here. So either we can rate it as 5 or 8. Okay, so like that, as you keep increasing the numbers, the more and more numbers keeps missing. That's why one of the guidelines is that maximum is to go up to 40 number. Anything beyond 40, okay, then such user stories should be treated as epics. They are large user stories. Okay, so less than 40 is any user stories which are having less than 40 story points, they should be treated as a development user stories. Okay, and if going beyond 40, then you have, in case such user stories going beyond 40, you have to start splitting them. Okay, next, the linear scale. Coming to the linear scale, here it is straightforward. Directly you have to estimate whether user story is 1 point, 2 point, 3 point, 4 point, 5 point, like that. Okay, so this is very straightforward. And there is also one more type of unit which makes use of t-shirt size. So t-shirt size here starts with X, extremely small. Extremely small means XS. Okay, and next one is small, next is medium, large, extra large, and double extra large. So what you can make use of this t-shirt size to rate or to determine the size of the user story. Like if you feel a particular story is extremely, it takes very less amount of effort. Let's say less than a day or less than half a day. Okay, less than half a day, let's 2 hours, 3 hours. That is the smallest amount of effort a particular story takes. Then you can treat them as extremely small. And if any other story takes a little bit more than the smallest, then that story can be treated as small. And then little bit more, then you can treat such stories as medium. Like that, you can go up to double XL. Okay, so these are the type of scales normally we can make use of in estimating the user stories. Okay, so out of this, Fibonacci scale and t-shirt size is more popular, and linear scale is not very widely used because again it expects you to be more accurate, like you have to tell it is exactly 2 times, 3 times, 4 times. Okay, so the whole point of using story points and relative estimation is to proceed with less time and quicker. Okay, so when you are going to do the linear scale, then it expects you to be more accurate, and in that process you may take more time. So okay, so there are some questions. Let me see. Okay, the question from Ajay is what is a point or a size? Okay, okay, point is a number. Point is a number, a random number which we give for any user story or a feature. So which determines the size. Okay, the size is include, you have to tell some quantum of a size. So the point is one of the units, the story points is one of the units used to uh, determine the size of a particular feature. Is it clear? Okay. What is the maximum t-shirt size taken for development? As you have told, 40 story points is the limit in Fibonacci scale. Double XL. The maximum size is double XL. Is it clear, Balaji? Okay. So now let's move on. So let us say we have a 10-day sprint, 2-week sprint. Let's say 4 people working for that sprint. Okay, and in the 10-day, 2-week sprint, they finish X amount of work, which is equivalent to 40 story points. The volume of work what they finish. Do not worry about how many features they are finishing or how many user stories they are finishing. Just assume the total volume of the work that was accomplished in 10 days with 4 people is 40 story points. So that means assuming 8 working hours, equals to 80 hours for 10 days, and 4 people working comes to 320 hours. Okay, so that means in 320 hours the whole team has delivered 40 story points worth of work. So that means on an average each the entire team will take 8 hours to finish 1 story point worth of work. Okay, so this is some sort of an indicator of a speed in which they are going. So if they take more hours, that means they are slow. If they are taking less hours, they are faster. Okay. Similarly, there is also one more unit that is used, that is called ideal days. Okay, this is another alternate estimation technique. Okay, so why we call it ideal days is uh, there are 3 conditions should be satisfied when we estimate. Here we estimate in terms of days, and we call them ideal days because it assumes that all of you should be working on the project, which is once again an ideal situation, and there is no interruption at all, and everything what you need is completely available. So all these 3 conditions, assuming they are satisfied, and then you estimate the total number of days of a project, then it is called ideal days. Okay, and when you are estimating in terms of ideal days, you have to be a little bit clear about the actual time the project is going to take, the elapsed time. So example, let us say there is a soccer game. The soccer game, the standard duration of soccer game is 90 minutes. But normally the soccer game will not get over in 90 minutes when we really calculate the elapsed time. The elapsed time always takes more than the standard 90 minutes because there will be some delays in the project, in the soccer game. The player will get injured, or there will be some, let's say it starts raining or like that. So the play gets suspended temporarily for some time, or because of certain delays. When we calculate the elapsed time, it takes more than the ideal time. So when you are using ideal days, you have in your software project, you have to be clear whether you are talking in terms of ideal days or whether you are talking in terms of real number of days, elapsed days. And again, the understanding of what is ideal also has to be clear. Like one person may assume some X in a week, 3 days as ideal days. Other person may assume 4 days as an ideal days. So there is also an ambiguity in this kind of situation. That is why the ideal days kind of estimation is not very popularly used. More and most popular unit is story points based estimation. Okay, so because it does not have any such kind of ambiguity like ideal story point or a real story point. There is also one more unit called velocity. Velocity is nothing but it tells you how much amount of work a team can finish in a given amount of time. So how do we determine the velocity in a given amount of time? The given amount of time is a sprint or iteration. So how much each team can finish in every sprint. So that means how much means in terms of story points. How many story points the team can finish in every sprint. So then that will decide the velocity of the sprint of the team. Okay, so let us say how do we calculate the velocity. So one of the ways of calculating velocity is by past data. Let us say we have 3 iterations the team has finished. The iteration 1, team finished 3 product backlog items, and the total number of story points they finished is 90 story points. In the second iteration, team accomplished 120 story points. The third iteration, team accomplished 100 story points. So now you take the average of all these, okay, which will be approximately 105 story points per sprint or per iteration. So this is called velocity. So velocity is nothing but what we can say in this case is, on an average, this team can deliver 105 story points per sprint or per iteration. Okay. That doesn't mean that every time they deliver 105. Sometimes they may deliver less. Sometimes they may deliver more. Okay, this is one of the ways of calculating velocity. Suppose you don't know the past data, then if suppose the team is starting the project, then they can run the iteration and then calculate the velocity. Okay, so like let us say the team is starting the first iteration or a sprint. Initially they'll do a guesstimate and then they calculate how much they accomplished here. Let us say they assume 10 story points and here they really delivered 15 story points. Then that becomes the new value of the velocity, and the team will take that as a recalculated velocity. Then they'll commit that much amount of work in the second sprint, and again the team will measure how much actually they delivered. So let us say at the end of sprint 2 the team delivers 25 story points. Okay, at the end of sprint 2 they delivered 25, at the end of sprint 1 they delivered 15. So if the two add it up, 15 plus 25 is 40 and divided by 2 sprints. Okay, so 20 story points per sprint. So that will become the new velocity data for the third sprint. So like that, every time the sprint is started and every time the sprint is finished, before we start the new sprint, we recalculate the sprints based on the past sprints data. This is another way of determining the velocity when you don't have past sprints data. Okay, so the estimation levels in Agile, there are two levels. One is at product backlog level, another one is iteration backlog level. So in the product backlog level, this is used for release planning. The purpose of product backlog estimation is to do the release planning, whereas purpose of doing iteration backlog estimation is to commit for that particular iteration or a sprint. Okay, that unit used here, there is hours. Okay, so let's discuss how do we determine the product backlog size using one of the method called planning poker method. So now first, normally when we start the project we'll do the release planning. Okay, so let us now discuss how do we do the release. Before do the release planning, what are the things we do, how do we estimate the total product backlog size. Okay, so how many story points this product backlog has got. So for that we make use of method called planning poker method. This planning poker method is a modified form of Delphi wideband method which is used in traditional estimation. And here the planning poker method expects you to have the team. So it is a team-based estimation technique. It's not one or two individuals who perform the estimation and the experts who participate and they give the final figures. It's not like that. Here entire Agile team participates in and collectively they perform the estimation and they determine the product backlog size. Okay, so let us say there is a sample product backlog like this. So 1, 2, 3, 4, 5, 6. There are 6 features. Okay, assume each of these features, the size of each of these features are written here. So this one has got the enable all users has got 20 story points. Okay, the upgrade has got 5, investigation of solution has got 13. Okay, diagnosing 20, like that. So these numbers tells the size of each of the features or user stories or a product backlog item. Okay, now if you add all these things, then you'll get a total product backlog size. Let us say we add this, how much it will come? 20 plus by 25, so 13, 28, so total it comes to 69. So 69 story points. So the total product backlog, the product backlog size is 69 story points, which has got 6 user stories. Okay, now assume 69 you make it as 70 story point. Let us say our velocity of the team is 10 story points per sprint. So if the velocity of the team is 10 story points and total product backlog size is 70 story points, how many sprints or iteration we will need to finish all these product backlog items? Could you please tell me the answer? 7. Okay, 7. Mike says 7. Yeah. So that means 7 sprints or 7 iteration it takes. So this then our release planning is done. So if you know the product backlog size and if we know our velocity, then we can determine the number of sprints. So when we do a release planning. So now let us discuss how to determine the size of the product backlog. So for that we should know the size of each of these product backlog item. So how do you say this is 20? How do we say that this is 5? How do we say this is 13? So for this we make use of planning poker method. So we will discuss how do we do this, and we will also do a small exercise which will help us to understand this better. Okay. So the one thing is when we starting this, first we should know the reference user story or a reference product backlog item. Like example, we decide bedroom takes two points. Then all other rooms we estimate relatively with respect to bedroom. Like that we should have a reference product backlog item here. So one of the ways of determining the reference product backlog item is the smallest number. The smallest number, normally we take the smallest product backlog item as a reference user story or a product backlog item. Okay. In this case, enable all users to delete items on their wish list is 3 numbers. So this is the smallest. So how do we determine this? Entire team should go through all the features. When they go through all the features, okay, enable all users, it is okay, it takes a bit more time. In transaction processing, it is a little bit lesser. Okay, we may not know the exact number, just we have to do a brainstorming discussion when these features are given to the team. So when we do a brainstorming discussion, you may find, okay, I think just deleting items on the wish list doesn't take much time. So then let's give some number for this. So in this case, this team has given 3 story points. So there is nothing significant that you have to give 3. You can give 2, you can give 1. So then that gives a reference number, and all other user stories, rest of the all other product backlog items should be estimated relatively with respect to the smallest product backlog item. Okay, so that is the first thing the team has to do before doing the planning poker exercise. Okay. Once the reference user story is identified, once reference product backlog item is identified, then we'll start the planning poker exercise. The planning poker exercise, some people they make use of poker cards. Like if you look at the numbers here, these numbers are following Fibonacci series. Okay, and this expects and all team members to be there for doing the estimation, irrespective of their experience. Okay, so that's the beauty of this exercise. So let's discuss how this is done. So the planning poker exercise expects you to have one moderator who will moderate the entire estimation exercise. So the moderator normally will be a scrum master. The scrum master is going to be a moderator who moderates the entire planning poker exercise. Okay, now we assume the team has decided the reference user story. Okay, then they start estimating the topmost item in the product backlog. Because topmost item is the one which is having highest priority, you should start with that one. Okay, and product owner also will be the part of the exercise, and product owner may not take part in the estimation. Product owner will play a role of, in case team needs any clarification with respect to the requirements of that particular product backlog item, he will help the team to strengthen their understanding. Okay, so that's the role of product owner. He will not take part in the estimation. He will not give any estimation numbers. Only the Agile team will, the different cross-functional team members will give the estimation. Okay, so let us say we start with the first estimation, first product backlog item. Okay, so then the team here we can agree on first round. We are going to start the first round. How much time each round is going to take? Okay, let us say every round we take a call, that 2 minutes. Okay, the first round will take 2 minutes. Like that, every round will take 2 minutes. So after the first round, the first round, the entire team, every team member will do an estimation individually. He will not discuss with others. Okay, none of the team members will discuss how he or she is going to do the estimation with the other team member. They will do privately and they will not reveal the numbers. Okay, and this is done up for 2 minutes. Okay, they can consider in general like what are the development work, break it the whole work into development and testing. So how many story points for development and how many story points for testing they can add and come up with a total number of story points. You do not have to be exactly worried about getting the right number. It's basically a relative number. Okay. So at the end of the first round, the 2 minutes, the Scrum Master will ask the rest of the team members to show their cards. He will say, say 1, 2, 3, show. So moment Scrum Master says 1, 2, 3, show, the teams can show their cards. Okay, at the same time. So when every team member is holding that card, then Scrum Masters will look at the numbers. Okay, so let us say there are 4 people participating in this exercise. Okay, so first member, when the Scrum Master says 1, 2, 3 shows, he says his number is 3 story points. The second team member says my number is 8 story point. The third team member says my number is 11 story point. And the fourth team member says my number is 40 story point. So which number you will take it? So it is not so easy, right? So any suggestions from you? Which number you will take out of these 4 numbers? Yeah, so it is not that easy. So what Scrum Master will do is, he will see, we have to agree on one particular number. Now there are all these 4 numbers are quite different. Maybe 8 and 11, the second and third number, not too much difference, but the first member and last member, the first team member has estimated 3 story point, and the fourth team member has estimated 40 story point. There are a lot of variance between these 2 numbers. So the Scrum Master will take these 2 people, highest estimator and lowest estimator, and normally starts with the highest estimator. Okay, now you will ask the 4th team member, can you please tell me why do you think the 40 story point is the number which you are given? Then the 4th team member will now start explaining this to the other team members. When he is explaining, the others will start comparing how they did the estimation with respect to what the 4th team member has done. During that process, they might have missed out certain things, or they might not have missed out. In case they want to change the number, they can change. In case they do not want to change their number, they don't have to change. Okay, so let us say none of them do not want to change. Then the Scrum Master will go to the lowest estimator. It is the job of the highest estimator to convince the rest of the team member. If the highest estimator cannot convince, then the next option is to go to the lowest estimator. And assume that lowest estimator also could not convince, then the Scrum Master will not waste his time. He will say, let's go to the second round. So in the second round, again team will spend 2 minutes, and again the team will give different numbers. Okay. In the second round, let us say the team gave the first team member has revised his number to 5. The second team member still kept 8, and the third team member may be 11. Okay, and fourth team member who from 40 he revised it to 25. So again there is a difference between 5 and 25. There is too much difference. So again these 2 people will become highest and lowest estimator, and the discussion will take place. And if the numbers cannot be convinced, it will go to the third round. Okay, so as and when we keep increasing the rounds, the number starts coming, getting converged. So finally, maybe after a few rounds, then the team may agree on particular number. Okay, only when they agree on the particular number, they'll go to the next product backlog item. So they will finish like that for all product backlog items. Okay, so like example, so the first product backlog item, this would have taken 4 rounds. So maybe you can see the first round how much was the variance, second round it reduced, third reduced, and fourth it was still lesser. So maybe at the 4th round it is easier to come to the converged value. Okay, but the point is that they have to agree on one number. It's easy to agree one number here rather than agreeing to one number here. Okay, so like that the team should go up to as many rounds as possible till they get convinced. Okay, here the moderator role, the scrum master's role becomes very important. So he has to play the role effectively. Okay, so like that he has to moderate.